And so I've worked with computer image analysis engineers that can identify these animals and then extract the XYZ coordinate of the initial impact point.
We have walked on the moon, sent rovers to Mars, and explored planets millions of kilometers away. Yet the deepest parts of our own planet remain almost completely unknown. Every expedition into the deep ocean returns with creatures that seem completely bizarre and unnatural. Because deep down, sunlight disappears completely. Pressure becomes strong enough to crush a submarine into pieces. Temperatures go near freezing, and food becomes extremely scarce. And for life to survive here, biology has to change completely, turning this place into an eerie alien world. In this video, we will take you from the surface of the ocean to the deepest parts no one ever talks about, and show you why life there looks so creepy and disturbing. Let's dive in. Where sunlight dies. On the surface, the ocean looks alive in a way we can easily understand. Sunlight, movement, color, everything visible. This upper layer, only about 200 meters deep, holds more than 90% of all marine life. Almost everything we know about the ocean exists in this thin slice, powered completely by sunlight. Because sunlight is not just light here, it is energy. Tiny drifting plants called plankton use it to create food, and that single process supports the entire ocean food chain. Fish, sharks, whales, all depend on this surface engine. But this system has a hard limit, and once you cross it, everything starts changing fast. Around 200 meters down, sunlight starts losing its strength completely. Not slowly, but like something shutting off, piece by piece. Red light disappears first, just a few meters down. Then orange, then yellow. By around 150 meters, the ocean turns into a deep, cold blue. And by 200 meters, human eyes can barely tell if it is day or night anymore. It is not darkness yet, but it is no longer light either. This is also where pressure starts to feel unreal. Every 10 meters adds another full atmosphere pushing in from all sides. Even temperature drops sharply to near freezing, around 4 degrees Celsius. But right below this point, something even stranger begins. The twilight zone, stretching from 200 to 1,000 meters. It is the largest living space on Earth, yet still one of the least understood. No plants exist here. No sunlight reaches here. Life depends on what falls from above. A constant, slow rain of dead plankton, fish waste, mucus, and tiny fragments of organic matter. Scientists call it marine snow. But it is not gentle. It is more like a drifting layer of organic waste that barely survives the journey down. Most of it is consumed long before it reaches these depths, which means the deeper you go, the less energy is left for anything to live on. And that changes everything about survival. Many creatures slowly shift into a different way of living. Bodies become soft, almost structureless, designed to save every possible bit of energy. Some stop active hunting completely, turning into floating traps that survive only when something drifts close enough. In this world, being seen is often a death sentence. So some animals take an even stranger path. They erase themselves visually. Bodies become completely transparent. Internal organs shrink into compact hidden clusters, and even their eyes change in ways that stop them from casting visible shadows. The glass octopus is one of the clearest examples, suspending in open water, almost invisible. Even its organs are packed so carefully that light passes straight through its body without revealing its position. But in a place like this, disappearing is only one side of survival. Because not everything here survives by hiding. Some begin to do the opposite. Creatures made of light. In the deepest parts of the ocean, light does not come from the sun anymore. It comes from life itself. Inside many deep-sea bodies, light is created through a chemical reaction. A substance called luciferin mixes with an enzyme called luciferase, and when oxygen is added, light appears instantly. And almost all of it is blue-green, because these colors travel the farthest through seawater. But this light is not for beauty. It is survival. Many predators hunt by looking upward, waiting for silhouettes against faint surface light. Even a small shadow can reveal everything. So some animals learned a strange solution. Instead of avoiding light, they produce it. They glow along their undersides using special light organs. The brightness is constantly adjusted to match the weak light coming from above. From below, the body disappears completely. The firefly squid is one of the clearest examples. Its body is covered in thousands of tiny light points, flashing in coordinated waves. These flashes are not random. They can help it communicate, confuse predators, or simply blend into the faint glow of the ocean above. But light here is not always defensive. Some creatures turn it into a weapon. The dragonfish produces a deep red light, a wavelength most deep-sea animals cannot see. To everything around it, this beam is invisible. But to the dragonfish, it works like a private searchlight, revealing prey without warning them at all. Other fish carry living lights under their eyes. These lights are produced by bacteria living inside their bodies. The fish controls them like shutters, turning them on or off depending on need. Certain worms take a different approach. They release small glowing decoys that float away in the darkness, drawing attention toward them, while the real body slips away in the opposite direction, completely unnoticed. Then there is the anglerfish. It does not chase anything. It waits. A glowing bulb hangs in front of its head, produced by bacteria trapped inside. The fish moves it slightly, like a living bait. In the darkness, even that small movement is enough to bring prey closer, straight into its jaws. So, in the deep ocean, light is no longer simple. It is created, controlled, stolen, and weaponized. And yet, even this strange control over light is not enough for survival everywhere, because deeper down, something far more extreme begins to appear. The monsters below. Down here, survival is not about strength or speed. It is about not missing a single chance. Food in the deep ocean is rare. A meal might appear once a week, sometimes even months. And when it finally passes by, there is no second chance. Missing it means starvation. So evolution removes anything unnecessary and replaces it with one goal: perfect efficiency in hunting. That is why many of these creatures look less like animals and more like living traps. The anglerfish is the most striking example of this survival strategy. Its body is soft, with almost no real bones to support weight. That might sound like a weakness, but in the deep sea, it is an advantage. No heavy skeleton means almost no energy wasted. It can sit motionless in the dark for long periods, waiting for something to come close enough to catch. And when something does, there is no escape. The viperfish strikes like a spring-loaded weapon. Its skull snaps upward, while its lower jaw shoots forward in an instant, piercing anything in front of it before it even has time to react. The fangtooth takes a different approach. Relative to its body, it has the largest teeth of any fish on Earth. It mostly detects movement through pressure changes in water, because its vision is extremely limited in the darkness. Then there is the gulper eel. Its entire body is built around one idea: swallowing anything, no matter the size, waiting for anything unlucky enough to enter. But perhaps the most dangerous adaptation is not size or teeth, it is invisibility. Some deep-sea predators have developed ultra-black skin that absorbs almost all incoming light. Even in front of a bright bioluminescent flash, their bodies do not reflect anything back. They do not just blend into darkness, they erase their outline completely. In this world, even seeing them for a fraction of a second is rare. And yet, all of these adaptations share one limit. They only matter when prey is close enough to catch. But down here, that moment is rare. Sometimes it doesn't come for even months. And when survival depends on something that rarely arrives, evolution starts to change in ways that feel completely wrong. Evolution gone wrong. In the deep ocean, even something as basic as finding a mate becomes almost impossible. This world is so vast and dark that two animals can wander for years without ever meeting. There is no light, no clear direction, no signals that travel far. So, in this environment, survival stops following normal biological rules. One of the clearest examples is how reproduction itself gets redesigned. In some deep-sea species like the anglerfish, males are born extremely small and are built with almost no long-term survival ability. They cannot rely on food, and in many cases, they only have one chance to locate a female before they die. So, to do this, they depend on chemical traces in the water, following faint signals that spread through the darkness. When they finally succeed, something bizarre happens. Instead of separating after mating, the male becomes permanently attached to the female's body. Over time, his organs shrink, and his body is slowly absorbed, leaving him reduced to a living reproductive extension. It is not cooperation anymore. It is survival through physical fusion. But reproduction is only one area where evolution starts breaking familiar patterns. Even basic senses begin to disappear. Vision, for example, becomes a heavy cost in deep water because there is almost no light to process. The brain structures that handle vision also consume valuable energy, but down here, energy is scarce. So many species slowly lose their eyesight over generations. Some are left with only tiny, non-functional eyes, while others abandon sight entirely and read the water through pressure changes alone. And then, the body itself begins to change. At extreme depths, pressure is so intense that solid structures become less efficient. Instead, many creatures replace them with flexible cartilage. Floating also becomes a challenge. Near the surface, fish rely on air-filled swim bladders to control buoyancy. But under deep pressure, those air pockets would collapse instantly, crushing the body from within. So deep-sea species abandon them entirely. Fish like the viperfish and others instead rely on body oils and fats that naturally match the surrounding water, allowing them to hover without energy loss. At this point, evolution is no longer building animals in the usual sense. It is stripping them down to whatever still works under impossible conditions. And yet, even these extreme limits are not enough to explain what comes next. Because deeper in the abyss, something begins to happen that changes the scale of life itself. Giants of the abyss. In most shallow waters, animals like shrimp, woodlice, and small crustaceans stay tiny. But in the abyss, the same family of creatures grows into something completely different. Almost unrecognizable. It is as if the rules of scale are reversed. This is called deep-sea gigantism. The deeper and colder the environment becomes, the larger some creatures grow. Cells divide more slowly, but expand more. And the cold water slows down internal chemistry so much that bodies end up developing into massive forms over time. But not all giants are scavengers. The colossal squid takes this idea to another level. Weighing hundreds of kilograms, it is one of the largest invertebrates ever discovered. Its tentacles are not just soft arms, they are armed with rotating hooks, sharp enough to grip prey firmly in complete darkness. It does not rely on sight in the usual sense. Instead, it uses enormous eyes, built to detect the faintest traces of movement. These eyes are so large that they can be compared to the size of a soccer ball, designed to capture even the smallest disturbance in deep water light. And above them all moves one of the slowest giants of the deep, the Greenland shark. It can grow up to 7 meters long, but it moves at an almost unbelievable pace, slower than a walking human. Its growth is so slow that it takes around a century and a half just to reach maturity. Some individuals have been confirmed to live for over 400 years, making them the longest-living vertebrates on Earth. A single shark swimming today may have been alive when early modern history was still taking shape on land. But why does everything become so large down here? Actually, deep water holds more dissolved oxygen, and because so few organisms live there to use it, that oxygen stays available for a long time. But at the same time, the extreme cold slows every biological process down to a crawl. Energy is used so slowly that survival depends less on speed and more on efficiency. In a system like this, size itself becomes an advantage because larger bodies lose energy at a much slower rate to the surrounding water. But even these massive, slow-moving giants are still bound by one truth. They survive only because something keeps falling from above. And when it finally reaches the deep sea floor, it does not just become food. It becomes something else entirely. The world of the dead. In the deep ocean, death does not mean an ending. It becomes an event that changes everything around it. When a whale dies at the surface, its body begins a slow fall through thousands of meters of darkness. A single 40-ton whale carries more energy locked inside it than almost anything else in the ocean. When it finally reaches the seafloor, it delivers a sudden explosion of nutrients, equal to thousands of years of normal marine snow falling in one place. For the creatures below, it is not just food. It is a rare moment where the entire ecosystem suddenly wakes up. Within hours, the first wave arrives. Giant isopods, deep-sea amphipods, and sleeper sharks gather in massive numbers, tearing into the body and stripping away flesh at a shocking speed. Then, something stranger begins to happen inside the carcass itself. Hagfish, blind and jawless, burrow directly into the whale's body through natural openings. They do not fight the outside world, they simply enter it. Inside the carcass, they feed from within. And when threatened, they release a thick slime that expands in water, clogging the gills of anything trying to attack them. Cover the skeleton completely. They have no mouth, no stomach, and no eyes. Instead, they grow root-like structures that release acid and carry bacteria capable of breaking down bone from the inside. And even after all flesh is gone, the whale is still not finished giving life. The skeleton slowly becomes a long-term ecosystem, supporting life for decades. But the ocean has another way of sustaining life in the deep that does not come from above. Here, microbes use a process called chemosynthesis, turning hydrogen sulfide and other chemicals into energy. Around them grow entire ecosystems, including giant tube worms that have no digestive system. Their bodies are filled with symbiotic bacteria that feed them directly from within. It is a different kind of life, built entirely on chemistry instead of light. And yet, all of this still exists in a world that feels strangely familiar. But beyond this point, the ocean stops feeling like Earth. It feels like another world entirely, one that operates under completely different rules. Earth's last alien world, at the very bottom of the ocean, where the surface is no longer even a memory, the world enters its final and most extreme form. This is the Hadal Zone, the deepest region of the ocean. It runs from 6,000 meters down to nearly 11,000 meters, inside vast trenches formed where tectonic plates crash and slide under one another. The deepest known point is the Mariana Trench. Challenger Deep, a place so deep that if Mount Everest were dropped inside it, its peak would still sit more than 2 kilometers underwater. Here, pressure reaches nearly 8 tons per square inch. It is so extreme that any normal structure would collapse instantly, as if the ocean itself is trying to erase anything that enters it. And yet, life is still here. The deepest known fish, the Mariana snailfish, survives at depths around 8,000 meters. It looks almost unreal, translucent, soft, almost melting in shape. At these pressures, normal proteins would be crushed out of existence. But this fish survives by using a special molecule called TMAO, which acts like internal support, preventing its cells from collapsing under the weight of the ocean. Below a certain point, even fish stop being possible. Scientists estimate that beyond roughly 8,200 meters, the physics of a fish's body simply fails. Only simpler forms of life remain. Worms, jelly-like creatures, and microbes adapted to conditions that would instantly destroy most biology. But there is an even bigger question waiting beyond this point. Because conditions like these, complete darkness, crushing pressure, and life surviving without sunlight, may also exist far beyond Earth. Scientists believe massive oceans are hidden beneath the frozen crusts of Jupiter's moon Europa and Saturn's moon Enceladus. These oceans are sealed under kilometers of ice, with no access to sunlight at all. And if life can survive in Earth's most extreme underwater environments using heat and chemical energy alone, then the possibility of life existing in those hidden oceans suddenly becomes far more real. And if something is living in those oceans right now, we have no idea what it would look like. So, the deepest parts of Earth are not just extreme environments, they are previews of alien worlds. Every new expedition still brings back species we have never seen before, as if the Earth is still hiding its final secrets in plain sight. This leads to a very uncomfortable question. How many forms of life could still be hiding in the parts of Earth we haven't explored? And if we barely understand our own planet's depths, how confident are we about anything beyond it? Let us know what you think about this in the comments below. If you enjoyed this video, make sure you give it a thumbs up. And if you don't want to miss more crazy videos like this, subscribe to the channel. We will see you in the next one.